Hi, I'm John McDonough from Fortinet, and I'm talking about cloud security from left to right, intelligent, integrated, and automated. I'm here on behalf of my team, Brent Martinez and Shrija Reddy Alam. We are the Azure team at Fortinet. We specialize in Azure architecture and Azure DevOps. And I want to talk to the developers today about securing your code. The code that is your application, also the code that defines the infrastructure where your application runs. I want to show you how we can secure that code, and then once your application is running, how we can secure it with the FortiGate next generation firewall and automate the FortiGate to interact with the Azure environment and dynamically update based on the Azure environment and reach out to Azure to enact change. Whether we're using an Azure Runbook or an Azure Function app, we can do that right from the FortiGate and enact change dynamically, intelligently, and in an automated fashion. Behind all of our products is FortiGuard Labs. FortiGuard Labs is the leading threat intelligent service from Fortinet that takes billions of feeds per day and distills them down to actionable intelligence by all of our products. It is a key component in our code scanning, as well as our application scanning, and of course, our next generation firewall. The two code scanning applications that I want to talk about today are FortiDevSec, or SAST, Static Application Security Testing, and FortiDAST, Dynamic Application Security Testing. For Fortinet, we cover the entire CI/CD lifecycle. FortiDevSec covers your infrastructure as code as well as your application code, scanning for well-known and recently discovered by FortiGuard Labs security issues that may be part of your code. FortiDAST then allows us to take the running application and do penetration testing, dynamically testing the application to determine where there are issues within the application and how can we secure that application. FortiDevSec covers security or static source code scanning. It covers secret scanning. It covers scanning for issues in third-party source code, as well as infrastructure as code, scripts like Terraform or shell scripts, and container scanning. With the static analysis done, your CI/CD pipeline, depending on the risk that is determined of your code, can either go forward and build the application, or it can fail the pipeline before going on to dynamic application security testing. Within the pipeline, if FortiDevSec risk rating allows the pipeline to move forward, the application can be built and deployed, and then FortiDAST can be enacted to scan your application. FortiDevSec can be integrated into existing code bases or used right from the beginning. Your code's written or you just started working on it, the first thing you do is create an application in FortiDevSec. Now, FortiDevSec is a cloud-based or SaaS-based solution. You start by creating a new application and providing a name. We've distilled down the OWASP top 10 risk rating calculator to two questions. What would a full breach of this application be? Would it be virtually no impact all the way to catastrophic? And where's the application deployed? Does it require physical access all the way to on the internet? Now, each one of these, let's choose on the internet, each one of these two questions provides weighting to the risk that gets calculated based on the security issues that are found within the code. You can integrate with Jira. By doing this, any issues that are found, and as they're updated by FortiDevSec, those will be updated or created within Jira. And then your app is done being set up. There's a scanner configuration file that gets downloaded, and that has an application ID along with your organization ID. And what that does is it ties your application back to FortiDevSec. So when you check in your code and in your CI/CD pipeline, you invoke FortiDevSec, that's how the application configuration file is how FortiDevSec knows where to update within the FortiDevSec SaaS application. So now I have a new application called MS Build 2023, and it hasn't been scanned yet. We're going to take that application configuration file that was downloaded from FortiDevSec and integrate it into our code. So I'm copying the FortiDevSec YAML file that was just created to the root of my code repository, the root of where my code is. And I can take a look at that, and it's a very simple file. It just has the organization ID and the application ID. Now when I check in my code, this file will be used by the pipeline, or in this case, a GitHub workflow, to determine how this application is going to be scanned or how this code is going to be scanned. That's all I really need. FortiDevSec will determine that this is infrastructure as code, and scan it accordingly. But I do need a workflow to enact the scanning of my code. So you create a workflow just like any other workflow within GitHub. I've called this one FDevSec.yml. And this file just is triggered on a push to the main branch or a pull request to the main branch. It has one job in it, and that job is to check out the code and download the FortiDevSec container and scan the code. And so I'm going to go ahead and upload this repo, and we'll take a look at the code scanning in process. With my code pushed, if I go to the actions component of my repository, I see that FortiDevSec is running. With that FortiDevSec running, I can go ahead and check on what the status of the scan is. So FortiDevSec's completed running. We can go ahead and look at the FortiDevSec dashboard to see what was updated within our code, or what was found within our code. And FortiDevSec has found 11 vulnerabilities and assigned a risk rating of 7. Looking at the vulnerabilities, they're all within the infrastructure as code. Linux machine allows password authentication. Security group allows ingress from public internet. Security group rule allows ingress to RDP port. So these are things that we can act upon by changing the infrastructure as code and then rescanning. Or we can determine if these are allowable based on what this is supporting. This infrastructure may need to support some of the things that are here. So we can categorize these issues based on what is appropriate for our application. Or we can fix them and run the scan again. Adding dynamic code scanning is just as simple as adding static code scanning. We're going to add another task to our job in the GitHub workflow to invoke the DAST scanner. As well, we're going to update our FDevSec file to indicate where the URL is that we want to scan and how we want to scan it. There are a couple of options that can be set there. As well, I've also updated the FDevSec file here to fail the pipeline is if the risk rating is 7 or higher, the pipeline will fail and you won't go forward. You won't build the application. You won't deploy the artifacts that make up the application. You can stop your pipeline and look at those security issues before you go through the entire other process of moving through the pipeline. So you have the ability to fail the pipeline based on the risk rating. Once this is done, scanning, you can look at your FortiDAST dashboard to see what was found within that application. And the FortiDAST is also a cloud-based application or a SaaS application that you can utilize. Within FortiDAST, you have your dashboard that shows your overall scanning that's happened or is happening at that time if something is currently in scan. You have your scan policies. These are definitions of the applications that you want to scan, their URLs. You can configure those scans with a number of settings, authentication settings, what kind of coverage you would like, what exploit engine to use, if there's a WAF configuration, if there's Jira integration. So you have Jira integration with the static code analysis. You also have it with the dynamic code analysis. And again, it works the same way. Issues that are found are created, or issues that have changed are updated. It's really that simple. You check in your code, static analysis happens, dynamic analysis happens. Your pipeline can fail or go forward based on the risk security rating. And your code and your application are more secure. The infrastructure your application runs on and the code that makes up your application itself become more secure. Next, we're going to look at how we use the FortiGate Next Generation Firewall to automate and react to dynamic changes within the Azure environment. We're going to talk about Fortinet FortiGate and GFW automation. The environment in Azure that's being utilized is a single FortiGate with an external subnet, an internal subnet, and a protected subnet. There's an external interface and an internal interface. The external interface of the FortiGate is where unprotected, uninspected traffic is coming. The internal interface of the FortiGate is where the inspected traffic is exiting, or the return traffic from the backend workloads is coming back through the FortiGate and being sent back out to the requester. In this case, what we want the Azure automation to do, or the FortiGate automation to do in conjunction with Azure automation, is to ensure that two VMs in the same subnet cannot pass traffic between each VM without that traffic being inspected by the FortiGate. That's achieved by adding a host route to a route table. When a VM is created based on a tag that it has, the Azure SDN connector, which is a component of the FortiGate, will inspect the Azure environment and return to the FortiGate information about a VM and its particular tag. The Azure SDN connector returns, in addition to VM information, VNet information, subnet information, resource group information, all based upon the scope that's given to it. With the information that's coming into the FortiGate can respond by updating dynamic address objects by adding an IP address of a newly discovered VM or removing an IP address of a VM that no longer exists. When this happens, a FortiGate automation stitch will be triggered by a log event in the FortiGate. The log event will be the addition or deletion of a dynamic address based on what the Azure SDN connector has returned to the FortiGate. The FortiGate automation stitch will create a webhook that is sent to the Azure environment and received by an Azure automation account, and will trigger a runbook written in PowerShell that takes the body of the webhook coming from the FortiGate and utilizes that to update an Azure route table, either adding or removing a host route from the route table. So let's take a look at how that all comes together. So let's see how a FortiGate automation stitch and an Azure automation runbook come together in order to enact a change in the Azure environment, namely updating the route table by adding or removing a host route. So there's a couple of pieces on the FortiGate that we have to look at. Under Security Fabric, there's the external connector. There are multiple external connectors available, other private and public clouds, as well as other threat and feed services. In this case, an Azure SDN or an Azure connector has been created. And what this connector does is every minute, and that interval can be changed, every minute the connector goes out and reads the Azure environment at the scope that it's been given. What this Azure connector has found, or SDN connector has found, is all the information related to the resource group that this FortiGate has been deployed in. Azure SDN connector scope is related to the VM identity. That's what's being utilized to enable the privilege to read the Azure environment. The VM identity was given a role that allowed it just to look at this resource group. And within this resource group, several aspects of the resource group or several aspects of the Azure environment have been returned. The resource group name, some security group names, as well as instance sizes, subnets, etc. But the one that we're going to be triggering off of is the tag compute type and some value. So the Azure SDN connector will return these tags, and based on the tags, we can glean from it if there's an IP address associated to the entity with this tag. And from that, we'll create a dynamic address object. The dynamic address objects can be found under Policies and Objects, under Addresses. And the three that have been created for this example are app servers, DB servers, and web servers. And if we look at the definition of the web server's dynamic address object, we see that it is being updated by the SDN connector called Azure SDN. We're looking at private addresses, and we're filtering on the tag compute type where it's equal to web server. So what happens is the Azure SDN connector goes out, queries the environment, brings back all this information, and if there is an IP address related to the tag compute type, it will update the address object with that IP address. And we can see that there is an IP address associated to an entity or a resource out in Azure that has that tag. In fact, we can go ahead and look at that. If I look at one of these VMs, VM Linux 1 or VM Linux 2, So VM Linux 2 has a tag of compute type with a value web server, and its IP address is 10.125. If we look back at that address object, that in fact is the IP address that has been added to this dynamic address object. So we have the SDN connector retrieving the information and updating the address objects. When that happens, a log event is created. From that log event, we can trigger a FortiGate automation stitch. The FortiGate automation stitch is found under Security Fabric and Automation. An automation stitch is a trigger and multiple actions. A single trigger and then multiple actions can follow in an automation stitch. The stitch component is bringing together the trigger and the action. A trigger can be a number of things in the FortiGate. In this case, we're using a log event. An action can be a number of things. In this case, we're going to be using the webhook. The Azure Automation account has a runbook, and associated with that runbook is a webhook that will trigger the runbook when information arrives from some calling entity. In this case, it is the FortiGate. And the FortiGate is going to send along information from that FortiOS log. The information that's going to be sent along is the IP address that was either added or removed. And in addition to the IP address that was added or removed, we're also going to be sending along some predefined values: the name of the resource group, the name of the route table, the next hop IP address. Those components, along with the IP address and the operation, whether it was added or removed, which is gleaned from the event log, will trigger the Azure Automation runbook, and that will go ahead and update the route table. So in this case, what we do is create a stitch that brings together an update of a route table based on if it's a DB server in that compute type value, a web server, or an app server. Any one of those will trigger this automation stitch. So the trigger is a web server existence. In this case, or a DB server existence in another trigger, or an app server existence in another trigger. In this case, we're looking at a web server existence trigger. And when that web server exists based on a log event, or doesn't exist, right? So the existence of the web server is either it's there or it's not there. The action is to run something called route table update. Now that action is actually the definition of the webhook. And if we look at route table update, we'll see that there's a call out to a webhook in Azure. The body of the HTTP post request has the log action, whether the IP address was added or removed, and the address that was added or removed. We have the resource group name, the route table name, a prefix for the route so that we know it came from this activity or this automation, and the next hop IP for the route that we're adding to the route table. So just to put it all together, Azure SDN connector reads information from the Azure environment, updates FortiGate dynamic address object based on the existence or no longer existence of a VM that had a tag of compute type and a value of either app server, web server, or DB server. If any of those things happened, this action will be to send a webhook to Azure Automation. So what happens in Azure Automation? In Azure Automation, a runbook is triggered by something being sent via this webhook. In this case, it's a runbook called Update Route Table. And we can view the code. It's all PowerShell. This PowerShell extracts from the body of the webhook information about the resource group, the route table, the next hop IP address, the IP address, and the action that needs to be done upon that IP address, either add it or remove it from the route table. Once this PowerShell script runbook or PowerShell-based runbook runs, the route table will be updated. Now, initially when this was deployed, VM Linux 2 had a tag of compute type with the value web server. So as soon as that Azure SDN connector on the FortiGate ran and brought that information in, updated the dynamic IP address, it triggered Azure Automation runbook called Update Route Table to go ahead and add a route, a host route for that VM called microseg 10.1.2.5, and that is a route that forces any communication to that VM through the FortiGate. Use the contacts and resources below for more information on Fortinet and Fortinet products on Azure. We do have test drives available in Azure Marketplace. Thank you for your time.